hypothesis testing of a population proportion using the probabilities method. Two-tailed tests, where we're testing for a change in the population proportion, or to see if something differs, or if a question just says investigate whether the proportion is equal to something. Here H1 is not equal to. We need to split the significance level. So if you have a 10% significance level, we split it 5%, 5%. So 5% goes in the lower tail, 5% in the upper tail, and likewise here. The next example will demonstrate a two-tailed test. Example 3. Test to see if 1/3 of students cycle to college using a 5% level of significance. So H0, the proportion is 1/3, and it just says test to see. We're not looking for an increase or a decrease. This is a two-tailed test. So H1, proportion not equal to 1/3. Now we need a random sample. So in a sample of 10, one student cycled to college. Now we have to assume that the sample is random. It doesn't state that it's a random sample, but we have to assume that, otherwise the test is invalid. And the test statistic is equal to 1. Our binomial distribution next. So if H0, if this is true, then the number of students cycling, represented by X, follows a binomial distribution, where N, the number of trials here, is 10. There were 10 students in the sample, in our random sample, and P, the proportion who cycle from H0, is 1/3. So on the number line, X can take any value from 0 to 10. Here's our test statistic. N times P gives the mean. We're here. The test statistic is to the left of this mean. So we're going to test this tail here. So we calculate Px less than or equal to 1. And then we compare this probability to the significance level, but we need to split the significance level because we have a two-tailed test. So we're going to work with 2.5%. So we compare our probability, and it's greater than 0.025. So we have met this condition. We accept H0, and we need a conclusion in context that there is insufficient evidence that the proportion cycling has changed. Again, this part is from H1. For practice, try these questions. I haven't covered the critical regions method yet, so you need to skip a few of the questions.